Alright guys, today we're going to be talking about 10.1 volume of prisms and cylinders. Now this is something that we've covered in the past already, so it should be pretty straightforward for you guys. So just keep that in mind as we go through. But that's what today's focus will be, and this week's focus will be on volume. So please keep that in mind. So, getting started. 10.4 volumes of prisms and cylinders. First off, they ask, what is volume? Well, we know volume is the space inside a 3D object, when area was just the space inside a 2D object. So now we're just switching to 3D. That changes our formulas a little bit and our units a little bit. So to get started, first we have this rectangular prism here. It's very important that we know that this is rectangular. If we know it's rectangular, then this will work for all rectangular shapes no matter what, and this is the most easy formula that we have for volume. So, the volume of a rectangular prism is just length times width times height. Now it does not order does not matter when you multiply these, so I can multiply them in any way that I want. I'll get the same exact answer. Now this length times width, we can go ahead and shorten that into the area of the base. So if I find out the area of this top base here, that is length times width. And then I just take that area of the base and I multiply it by how long our prism is. Well, our prism is 2 here, so I'd multiply that area by 2. Now, with all volume equations, units are cubed. So we'll see inches cubed, meters cubed, feet cubed, centimeters cubed, any units cubed. Now, those are already written in your homework, so you don't actually need to write those in on the homework, but just know that our units will always be cubed when we're dealing with volume. And again, that's because if I say, okay, this is 4u, this is 2u, and this is 6u, well, then I can just multiply all those by each other. 4u times 2u times 6u. 4 times 2 is 8, times 6 is 48. And then u times u times u is u cubed. So that's where our units cubed comes from. It's because we're multiplying it in 3 dimensions, and that also makes sense as well. So again, the important formula that we have on this page is the volume of a rectangular box. It doesn't matter if it's a square box, a rectangle, anything like that. It'll always be length times width times height, and that's how we'll be able to find that volume. So, go ahead and try out this problem on your own for a second, and then we'll be going through it together. All right. So for our first one, we have this rectangular box here. Again, we just use our formula. Volume is equal to length times width times height. And since order doesn't matter, I can just give variables to any of these. It doesn't matter which one has the variables. So I'll say, for instance, 20 is L, 5 is W, 15 is H. And when we multiply that all out, 5 times 20 times 15, we end up with 1,500 units squared. So that'll be our answer right here, 1,500 units, this should be units cubed, because again, we're using cube units now. So 1,500 units cubed. Next, a rectangular box with dimensions of 2 inches by 3 inches by 5 inches. Well, again, I'll just give these each a variable, length times width times height, and then when we multiply that out, we end up getting volume is equal to 2 times 3 times 5. 2 times 3 is 6. 6 times 5 is 30. And again, this should be units cubed. That should be a cube right here instead. And then our final one. Our final one is this rectangular prism down below. Once again, we use the same exact formula. Volume is equal to length times width times height. We give variables to each of these. And for this, we have 10, our length, times our width, 9, times the height of the prism, 8. So 10 times 9 is 90. 90 times 8 is 720 units cubed. So that's how we deal with rectangular prisms. Very straightforward. Just multiply length times width times height anytime that you have a rectangular prism. And again, I know that's a rectangular prism because our bases, the 2 shapes that are facing each other, they're the same. Now that's going to change with the volume of other prisms slightly. So for all other prisms, it's the same exact formula, just length times width times height essentially. But in this case, length times width, that area of the base, That's just going to be the area of the base now. So whatever shape we're dealing with, whether it be a triangle, whether it be a square or rectangle, big B is always the area of the base. Now, just as a recap, bases are two of the same figure facing one another. So if I look at this triangular prism over here, I see that I have a triangle on one side, a triangle on the other, and they're facing each other. So I know that the triangles are the bases. If I were to take one of these lateral faces, one of the sides here, and I were to take the other side, well, it would not be the same exact shape facing it. So therefore, the lateral faces aren't our bases. Our bases will always be the same shape facing one another. Now, as we look at this first one, this triangular prism over here, we notice that it's kind of skewed to the side. It's leaning over. We call that an oblique prism because it's not going straight at a right angle, as we see with the second one and this third one where they're going at a right angle here. This oblique one is going at not a 90-degree angle, so therefore we call it oblique. Now, a big tip here. Height is always perpendicular to the base. So we know that our height will always be perpendicular to whatever base we're dealing with, and it must always intersect at 90 degrees. So if they give us an oblique prism, then we must still find the height, and we can use Pythagorean's theorem to do just that if needed. So Pythagorean's theorem will come into play with these. So go ahead and take a second, try and figure out number 3 on your own, and then we'll work through it. All right, so number 3, the area of the shaded face of the right pentagonal prism is 51. Find the prism's volume. So they say the area of the shaded face. Well, if I look at the shaded face here, that is our base. That's big B. So big B is equal to 51, and then I see that our height is equal to 7. So if I use our prism formula right up here, volume of a prism is equal to big B times H. We have volume is equal to 51 times 7, which will give us 357 units cubed. Again, we see that right here. 357 units cubed from multiplying the area of our base, big B, which is 51, times the height, which is 7. And that'll always be the case. Now, granted, if they didn't give us the area, then of course we could split this into triangles and then find the area of these triangles. And then once we find the area of one of the triangles, we multiply it by 1, 2, 3, 4, 5, and multiply it by the height. So that's a little bit more work, but if they already give us the area, all I need to do is take that area and multiply it by the height. All right, let's continue on. Go ahead and try this one out on your own. Find the volume of the rectangular prism. All right, so looking at this, I notice that it is a triangular prism. I mean, I just said rectangular. This is a triangular prism. And if I look at this triangle here, I notice that 2 of the sides are the same. So this is in fact an isosceles triangular prism. Now, if I notice that, then of course I can just go ahead and find the height. So if I go ahead and I draw an auxiliary line here, I know that it'll intersect at 90 degrees because it's isosceles. And I also know that it'll intersect at the midpoint, making both of these 6. So let's go ahead and find the height here. We need to find the height so that we can use the area of a triangle, which is 1/2 base times height of the triangle. So if we do that, we end up with this right triangle over here. So if I have this right triangle, then I can go ahead and say, oh, here's H. Here's this bottom part, 6. 6 is right over here. And then part of the isosceles is 10. From there, I can use Pythagorean's theorem. A squared plus B squared equals our hypotenuse squared, which will give us H squared plus 36 equals 100. Subtracting 36 from both sides, we get H squared is equal to 64. And then we go ahead and we take the square root of both sides to get rid of that square, which will leave us with H is equal to 8. So our height over here is 8 units. From here, we can find big B is equal to 1/2 our base, which would be 12 in this case, because again, our base is always perpendicular to our height, no matter what. So I have 1/2 of 12, which is our base, times 8, which is our height. Doing that will give us big B is equal to, well, half of 12 is 6, and then 6 times 8 is 48 units squared. So that's the area of our base. Now don't forget, we're trying to find out the volume here. So volume is equal to big B times H for any prism like this. So any triangular prism, anything that's pretty much not a circle, you're going to use big B times H for the volume. So we now have volume is equal to 48 times the length of our prism, which in this case is 15. So we have it right here. Big B, which is 48 units squared, times the length of our prism, which is 15 units. That's where this U is coming from. It's units. If I multiply this, 48 times 15 will give me 720. U squared times U to the first power will give me U cubed. So now I have volume is equal to 720 units cubed. And that's our final answer for the volume of this triangular prism here. All right, moving on. Volume of a cylinder. So, a cylinder is a prism with a circular base. What that means is that instead of a square or a rectangle, on top we now have a circle. The volume formula is the same, except we use circle terms. What that means is that I'm going to use the area of a circle instead of the area of a rectangle, a triangle, a polygon, any of those. We're just using the area of a circle. So nothing else changes. It's still volume is equal to big B times H, but in this case, big B is the area of a circle, which is equal to pi r squared. So I'm just taking pi r squared, plugging it in for B. Now, again, we notice that we have two different cylinders here, an oblique cylinder and a right cylinder. Now, if these have the same height in the same area of the base, they'll have the same volume no matter what. Even if one's slanted off to the side, as long as it has the same height in the same area of the base, they'll always have the same volume. So, again, height will always need to be perpendicular to the base, always at 90 degrees to the base, in order for us to find the height. I cannot take this slant height over here and use that as height. It must be perpendicular to the base. So again, the big thing here is just get this formula down. Volume of a cylinder is equal to pi r squared, that's the area of a circle, times the height of the prism. All right, let's go ahead and try this, a couple examples with this. So, example 1, find the volume of the cylinder. Go ahead and take a minute, try and solve this one on your own, then we'll work through it. All right, looking at this, we see, in this case, our radius is 5, because it goes from the center to an edge of the circle, so that means that's our radius. And the height of our prism is 12. So we have volume is equal to pi r squared times height. And if I look at this, again, radius is 5, height is 12. So then we just follow PEMDAS. So I must start with my exponents first. 5 squared gives me 25. 25 times 12 gives me 300, and then I just keep the pi attached to it. So 300 pi is our answer. Now, when you're going through your homework, it may ask you to round, so it may say round to the nearest tenth, in which case I'd multiply these numbers. Or it'd say keep your answer in terms of pi, which is just what this is. It means that I don't multiply by pi, it's just left on at the end. If that's the case, make sure that you know that pi is already included in the answer itself, because it'll have that at the end there right next to the units. So let's say volume is equal to 300 pi units cubed, and this whole part will already be entered in for you. You just need to make sure that you enter in the 300 here. That's going to be your important part. So just keep an eye out for that. If you don't, it may cause a mistake or two on your homeworks, and of course I go back through the assessments, so just be wary of it. All right, time for our difficult one, as difficult as these get. It says, find the volume of the cement needed to form the concrete pedestal shown. So, this is volume of composite figures. Composite figures are just figures, two or more figures that are put together. And in this case, we're going to find the volume of the cylinder
and then we're going to find the volume of the prism, and we're just going to add those two together. So that's all that we need to do with composite figures. Find the volume of one figure, then find the volume of the second figure, then add them together. That's it. So let's go ahead and do just that. First, the volume of a cylinder is, again, pi r squared times height. The volume of a rectangular prism is length times width times height. So I just go ahead and I plug in our values. I notice that my r value is 1, because that's our radius. The height of our cylinder is 5. Not the height of the prism. So these are two different heights here. These are not the same heights. Whoops. So again, this is not the same as this. They're both different numbers. From there, for our rectangular prism down here, our length is 4, our width is 3, and our height is 1/2. So from there, we just multiply that out. 1 squared gives me 1. 1 times 5 is 5, and 5 times pi is 5 pi. 4 times 3 is 12, times 1/2 is 6. So we have 5 pi plus 6 as an exact answer, and then if it said round to the nearest tenth, 21.7 is our rounded answer. Don't forget, the homework directions will tell you how to write your answers. So whether it be an exact answer or a rounded answer. That's all we got to do for composite figures. Again, find the volume of one, find the volume of the other, add them together. This is much more simple than surface area because I don't need to think which side is showing to the surface. It's only what amount fills this object. So it's all about just finding the volume and you're good to go. Much more simple than surface area. All right, lastly, homework is up on Schoology already. 10.1, volume of prisms and cylinders. If you have problems, email me with the problems that you are having on the homework. Be specific so that I can go ahead and help you out as much as I can with that. Stop by office hours. If you need any help, I'm happy to help you guys out with that. And then please stay safe, guys. I hope you all are doing well. I miss you all and hope to hear from you soon. Other than that, homework's up on Schoology, and have a great one, guys. I'll talk to you soon.